Important. And for my project, I wanted to implement a version of the breadth first search algorithm to find a path based on a user supplied grid, start point, and endpoint. Okay, so over here we can go ahead and choose the number of rows we want, the number of columns, which is 80, I put for this time, as well as a seed, and that's basically just used for reproducibility because the obstacles are generated randomly. I want to be able to recreate this grid again later, and I store this in the database as a specification for the grid essentially. So I generate this grid, and that also creates a post request in the server side to my database in Postgres using Axios, and thus I'm able to store those specifications. So from here now we can go ahead and choose the start point and the endpoints. So maybe here I will choose the endpoint here. And so it gives you a prompt you want to go ahead and solve. If you want to choose different endpoints, you just press cancel, choose different endpoints. But for here, we go ahead and say, okay, I'm happy, we'll solve. As you can see here, the algorithm found a solution and it returns that and highlights it as a path in our grid. Okay. Now, one more thing I want to share in this implementation is that there was a pretty interesting bug that came up, and basically this path result would be inconsistent or would just be weird. Sometimes it'll go through an obstacle, or sometimes it'll return no solution, but really there was a solution. And basically through some well-placed console logs, I was able to determine that the BFS logic was was not seeing the same grid as the grid that's being rendered in the front end. And that's because of the way that the seed variable is being stored here. The random number generator is getting different seeds, which means the grid it generates as different obstacles. So yeah, and I was able to resolve that by coercing this input to be an integer at all times, and I got the consistent results that I was expecting. Thank you.